Okay, let's look at page 55 in our pink math journal. I know, because we have lots of people absent today, and then sometimes if people miss class for a certain reason, they can go back onto Canvas and watch the video. I don't always do that for us, Raider, but I try to do it if we have kids absent so that they're not really missing out on much. They can do it as part of their makeup work. So thanks for noticing. You know what else? When I like to video, then you want to make sure to be on your best behavior. So your mom, because I could just send the video to your mom and dad and be like, hey, watch this video and see if you hear anything from your kid during class. So you always want to be super nice and following along, raising your hand, and not acting all crazy, Raider, when I got the video going, right? And then also, guess what? I always like to use my really nice voice, because I try to be really nice too, in case your mom and dad are watching. They won't be like, oh my gosh, she's so mean. So it works both ways. Okay, so on page 55, we are not quite done with division. There is a division standard that we did not even talk about yet. We're going to read this one together. This isn't a really important one, and it's a little bit tricky. Can we all read it together? I can interpret a remainder when given a word problem. What does that word interpret mean? What does interpret mean? Addie? Understand or decide what it means. If you didn't know what that word means, go ahead and underline it or put a box around it, and then draw an arrow. Decide what it means. What does it mean to the problem? Okay. So when we are talking about the remainder, there are 4 things that the remainder can tell us to do in a math problem. So I'm going to kind of come up here because I'm going to write 4 things. So I'm going to come way up here, and I'm going to not write really big. There are 4 ways to interpret a remainder. Okay? Number 1, the first thing that you can do with your remainder is, a remainder might mean to increase your quotient by 1. What does it mean to increase our quotient by 1? What is the quotient? What's the quotient? The answer without the remainder. So let's say my answer to my division problem is 7 remainder 3. If I increase my quotient by 1, then my answer to the story problem is 8, right? I just bump it up because I have a remainder. Okay, my remainder could also tell me just to drop the remainder. So if my answer is 7 remainder 3, then my answer to my story problem would just be 7. Okay? Should we maybe put that example there? If it's 7 remainder 3 in the first example, then my answer is 8. I just bump up that quotient. Okay? Here's my example. Again, if it's 7 remainder 3, then my answer would just be 7. And we'll do some examples of this together. Basically, if I say, there's 24 crayons, and I want to put 3, that's not a good, 7 remainder 3, 7, what would be 7 remainder 3? 40. Let's just go with something different. I won't try to come up with the right answer. If I say, all right, there's 26 pencils and I need 5 in each box, how many boxes do I need? If my answer is 5 remainder 1, I'm not going to say I need 5 remainder 1 boxes. That doesn't even make sense. I either need 5 boxes or I need 6, right? Not 5 remainder 1. Okay, the third thing that I can do with my remainder in the story problem is the answer can be the remainder. So the remainder could be the answer. So, for example, when I divide, if my answer is 7 remainder 3, my answer could be 3. Yeah, look, I froze. I'm frozen.
Got 4. It's frozen on.
Shh. Okay, so it says the remainder is the answer. It says example is 7, remainder 3. The answer is 3. Okay, and then the fourth one. So you need to be a good listener if it's frozen. The fourth one is the remainder could be changed to a fraction. And we'll have to do those examples later because I need a full problem for that. Okay, so we'll do some examples together on the next page.
I have to sharpen my pencil. I have to sharpen my pencil.
Okay, hurry up, please. Okay, so I'm turning it in 5, 4, 3, 2, 1. Okay, so in example number 1, we're going to drop our remainder. Okay, that was the second thing that we said we could do with our remainder in a story problem. So what should I do first when I'm looking at my story problem? What is something important to remember here? What should I always do when I look at my story problem? Ella? Yeah, I always want to start off with the cube strategy. Always. That never changes. So Susie has 16 flowers, and she wants 3 flowers in each vase. Put a box around the math action word. Underline the question. How many vases can Susie fill? How many? And then actually that word fill, because the vases have to be full. Okay? So when I divide, I might have a remainder in my division problem, but I should not have a remainder here. That wouldn't make sense to have like 2 remainder 4 vases. That doesn't make sense. There's no such thing as a remainder 4 vase, right? So I would either need 2 or 3 or whatever my division problem turns out to be. So 16 divided by 3. So she has 16 flowers and she wants 3 in each vase. Okay, that means I need to do 16 divided by 3. We should not even really have to do the Fantastic 7. How many times can 3 go into 16 without going over? Can we count it off? 3, 6, 9, 12, 15, 18. So how many times without going over? 5. So your quotient is 5, but how many are left? What's 5 times 3? 15. So when we subtract, I have 1 left. So my answer is 5 remainder 1. Can Susie fill 5 remainder 1 vases?
No.
That doesn't make any sense, does it? How many full vases of flowers will Susie have?
5.
What do you think, Gracie? 5. And then how many flowers will be left over not in a vase? 1. Okay, let's just quickly, another way to think through this is just to draw a picture. I'm sorry that the video is lagging for you, but if I drew a picture, let's just say these are my vases. 1, 2, 3, 4, 5. Susie can put 3 flowers in that one, 3 flowers in that one, 3 flowers in this one, and then she has 1 more flower. 3, 6, 9, 12, 15, and she has 1 flower left. Everyone should be writing this down. And when I come around, everyone should have this picture. Okay, now we have example 2. So in this example, let's just go with they dropped the remainder. We did not include the remainder in our answer, it was just 5. Now example number 2. It says increase the quotient to make the next greater number. Peggy has 23 markers, and she wants to organize her markers into boxes. Each box will hold 7 markers. How many boxes will she need for all 23 markers? So she wants to put each marker in a box. It doesn't say that the boxes have to be full. It just says that she wants every marker to be in a box. Okay? Okay, when we see that clue word each, it either means to multiply or divide. If the word each is in the actual question, we will usually, each box will hold 7 markers. How many boxes will she need? You have to read it to decide what it means, okay? But if we know that each box will have 7 markers, then we need to know that we need to do 23 divided by 7 to figure out how many boxes she's going to need, right? Okay, what is 23 divided by 7? How many times can 7 go into 23 without going over? I should see lots of hands. If you don't know, you might want to be looking at a math fact chart. How many times can 7 go into 23 without going over? Eli? 3 times. 7, 14, 21. Okay, and when I subtract my 21, how many are left? 2. Now, let's just draw a picture again for reference. So we're saying we have 3 boxes that each have 7 markers in them. 7, 14, 21. I have 2 markers left. Do I want those markers to be in a box? Yes. So I need a 4th box, but it won't be full. It would not make sense to put 3 remainder 2 boxes. Think through that. That doesn't make sense. I'm not going to say 3 remainder 2 boxes. You know what? His old school sent those books with him, Mrs. Garrett.
Oh.
So I need to talk to Mrs. What's her name? Mrs. Runkle about that.
I will let her know that. That seems weird.
It does seem odd to me as
We
well.
shouldn't have to pay for them, but really that should be a part of their inventory.
You have these 2 books with you, sir? Those 2 hardback reading books? I know, that's what I thought
If
too.
use your phone, I
No,
might
go ahead.
just be able to switch them out and
Okay.
interoffice mail
And send
them
those back.
to him.
Okay,
And then I have his lunch
thank you.
stuff and breakfast.
So how many boxes does Peggy need? How many boxes? 4. She needs 4. Because these 2 markers need to be in a box. It's $6,500 for Mrs. Runkle. Okay, example 3. The answer could be the remainder or what is left. Andrea, a florist, has 67 flowers and she wants to put 9 flowers in each bouquet. How many flowers will not be used for a full bouquet? Okay, I really just like to draw this picture. She has 67 flowers. She's going to put 9 in each bouquet. So here's a bouquet. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a bouquet of flowers. It would help if this would quit freezing.
So just go ahead and bring
1, 2, 3, 4, 5, 6, 7, 8, 9. That's our second bouquet of flowers. That's 18, right? 9 and 9 is 18. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's our third bouquet, and I'm up to 27 flowers.
books for him that you just like you sent for
1, 2, 3, 4, 5, 6, 7, 8, 9. That's our 4th bouquet, and I am up to 36 flowers. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is my 5th bouquet, and I have now used 9 times 5, 45 flowers. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is our 6th bouquet, which is 54 flowers. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my 7th bouquet, and that is how many flowers? 9 times 7 or 63. And then I can do 64, 65, 66, 67. Can I have another full bouquet? No. How many will not be used in a full bouquet? 4. Okay, so if we did that using division, it would just be 67 divided by 9. How many times can 9 go into 67 without going over? 7 times. 9 times 7 is what? 63, so I need to subtract that. It's 7 remainder 4. 7 remainder 4 flowers doesn't make any sense at all. How many will not be used? Another clue word for using the remainder for your answer is how many are left. Okay? Okay. Example 4 is changing our remainder to a fraction. Becca, I think this one's about me, has 18 inches of ribbon to make hair bows for the craft fair. She is going to make 4 hair bows. How long will each ribbon be? So I'm going to use all the ribbon. Okay? So if I have 18 inches of ribbon and I'm going to use it for 4 hair bows, how much ribbon do I need for each bow? I need to do 18 divided by 4. Okay, how many times can 4 go into 18 without going over? 4 times. What is 4 times 4?
16.
So subtract your 16. How many do you have left? 2. Now, so it's 4 remainder 2. To turn that remainder into a fraction, we take 4, and then the remainder is 2, and we put it over the divisor. So 4 2/4. 4 2/4. So each bow will use 4 2/4 inches of ribbon. Not 4 remainder 2 of ribbon. That doesn't make sense. 4 2/4. What is 4 2/4? What is 2/4? The same as what? What 2/4 is the equivalent to what fraction that we should all know? 1/2. So it's 4 1/2. Okay, I want you to look at page 55, and I want you to read this question. I want you to use the cube strategy, and then I want you to answer this question. You should not use the word remainder here in your question. You either need to bump your quotient up, drop the remainder, use the remainder as your answer, or change the remainder to a fraction. Okay? And then explain what you did. Okay? Everyone should be trying that now.